All right, let's begin our final analysis. This is analysis 14. It's record 15. We've highlighted it. We're going to go up here to add-ins. Easy has PDB menu, load parameters from PDB record, and we get our last analysis in. Now this is a tunable TISAF laser, and it can be tuned from 650 to 900. So how do we want to look at this? Well, the first thing we want to do is look at the wavelength of 650. It's visible, so we know our ANSI default is 1/4 of a second. Our ANSI default exposure duration is 1/4 of a second. That gives us the MPE we've seen before of 2.55 milliwatts per square centimeter. We can see that our worst case OD is 2.31. So for a visible wavelength, and visible wavelengths would be 650 up to 700, but not including 700. Now, in your book, the next wavelength we're going to look at is really going to be 700. In your book, it says 701. In the previous version of software, we included 700 in the visible, simply because that's how people thought about it. In this version of software, 700 is in the near IR, and that's because we're adhering a little closer to the ANSI standard at that point. So we know that from 650 through 699, we're going to have the same MPE, which means our OD value is the same through the entire visible region, which is 2.3. For the OD, we would round to 3. Let's look at 700. Okay, now we've moved to the near IR. We've noticed that the OD has gone up to 2.7. Why? Well, because the exposure duration went up. What happens if we actually put this at 1/4 of a second? You'll see it's the same as what it would be for 699. Right. So it's really the exposure duration that causes that OD to jump, and that's because 700 is in the near IR. Now, is this good enough from 700 to 900? Let me make sure I'm saying that. 700 to 900, yes. 700 to 900? Well, let's put 900 in and see what happens. Won't worry about that. That's just talking about the m² value. What happens is it drops again. So that's telling us really that the MPE, notice the MPE is 2.51 milliwatts per square centimeter. For 700, it's 1. So the MPE goes up with longer wavelengths in the near IR, making it less conservative. So our OD value in the near IR is 2.7. Again, we've rounded to 3. So from 650 to 900, the entire range, we'd like an OD3 in our eyewear to cover that. But let's take a look at why the MPE is increasing with wavelength in the near IR and not in the visible. Again, we're going to return to our standard. Let's look at table 5B. Here is 500 to 700. We can take a look anywhere in here at 1/4 of a second, and we're going to see that for 1/4 of a second in all of these ranges, 1/4 of a second MPE is calculated the same way. And you'll notice, yes, there is a time dependency, T, but there is no wavelength dependency in there. So that means for the entire visible, for a fixed exposure duration, which is 1/4 of a second in our case, we'll get the same MPE. What happens when we take a look at 700 to 1050, which would include our 700 to 900? Well, look at this. We see that it looks sort of similar for a 10-second exposure, and it doesn't matter which one of these lines we pick, we see there's a correction factor, C sub A. And what this correction factor does, C sub A causes a wavelength dependency through the range of 700 to 1050, and it makes 700 nanometers the more restrictive wavelength. So if we calculate using 700, if we calculate our OD value using 700 nanometers, that will give us our most conservative approach for the entire wavelength range. And since we typically round the OD value up, we see that even though there is a dependency, 700 is 2.7, 900 is 2.3, we would still round to an OD3. Okay? All right, you can check the other values, and if there are any questions, of course, ask the instructor. All right.